Thank you for joining us for this pre-recorded module of the Soil Builders Education and Action curriculum. Today we'll be talking about the drivers for clean water and soil health. I'm Natasha Duarte, Director of the Composting Association of Vermont. Our association believes that increasing the use of compost in our communities will improve soil health, water quality, and our resistance to climate change. The Composting Association of Vermont works to advance the production and use of compost as vital to soil health through practices that contribute to water quality, plant vigor, and environmental resilience, and to demonstrate the value of compost through education, policy, outreach, and partnerships to reduce waste, capture energy, and create jobs. I'm joined today by Elly Ventura. Elly started with the Lamoille Regional Solid Waste Management District in 2011 in a new position justified by the Universal Recycling and Composting Law. She continues to work for the district as the outreach manager, specializing in education of waste minimization, proper management, organics diversion, and communication. Elly was heavily involved in the writing and implementation of the Northern Border Regional Commission grant received by the district in 2016 that created the Lamoille Soil Organics Program and Processing Facility in Johnson, Vermont. She holds a master's in exercise science from Central Michigan University and a bachelor's in athletic training and psychology from Capital University in Columbus, Ohio. Elly joined the CAV Board of Directors in 2020. The Soil Builders workshops were developed to provide compost-related eco-literacy for Lake Champlain Basin decision makers, professionals, and advocates. Concerns about elevated phosphorus levels in the Lake Champlain Basin have contributed to confusion about when and how to use compost. There's a knowledge gap about specific benefits from using compost and how to modify current farming, site engineering, and landscaping practices to produce those benefits. Because we're not yet able to hold these workshops in person, we decided to provide the Soil Builders curriculum as a webinar series. The different modules in this curriculum will help you gain a deeper understanding of the connections between soil health and water quality, increase your technical know-how about compost, including compost-specific best management practices for a wide range of interventions, and learn how to support change of practice for road construction, development projects, stormwater control, and site remediation. I'd like to take just a minute to thank the Soil Builders Project partners, my board of directors for their oversight and input, and the New England Interstate Water Pollution Control Commission, who, in partnership with the Lake Champlain Basin program, provided generous funding for this project. Now, Elly's going to take us into the content of this module.
Thanks, Natasha. Again, my name is Elly Ventura, and I am the outreach manager for the Lamoille Regional Solid Waste Management District, so it makes sense that I'm going to talk about our national waste problem and its impacts. According to the EPA, the United States makes up about 4% of the world's population, but produces 12% of its trash. In comparison, China and India make up more than 36% of the world's population and generate only 27% of the world's waste. India's recycling rate is at about 66%, and here in the US, we're only recycling about 35% of the waste that we produce, and that also includes what we're composting. The only recycling rate I could find for China was what they were recycling for plastic only, and that was 22%. And here in the US, we only recycle about 9% of the plastic that we use. So the moral of the story is that we've got a lot of work to do. So how did we get here? I think we can probably all agree that we are a disposable, fast-paced culture. We're kind of a TikTok attention span society these days. And combined with that, there is an inconsistent or oftentimes even lacking infrastructure for recycling and composting across the country, making the disposal experience confusing and oftentimes even inconvenient. The receptacles and signage are rarely consistent in one building, let alone in the next town or state. So these inconsistencies make disposing of items correctly a challenging thing to do. It's an exercise in decision-making each time we want to discard something, which can be a frustrating and confusing experience that many people just won't take the time to do. But it's not only about the quantity of the waste that we're generating or creating that ends up in landfills, like Equally as important is the content, the actual type of materials that we're sending to these landfills. If there aren't clear options for collecting, recycling, and composting at the source where we're ready to discard these items, then everything ultimately is headed for a landfill. What those materials are and how they respond when they arrive at the landfill is really where the problems start. This slide that we're seeing here is from 2015 and shows that nationally, more than half of what we throw away could be managed differently. About 21% of the materials headed to the landfill are in fact food. Another 16% on the bottom are additional organic materials, yard trimmings and wood waste. And then the other 15% is paper or paperboard, which could be either recycled or composted. The makeup of our waste stream has really not changed since this graphic was printed. According to the 2018 EPA Facts and Figures on Materials Waste and Recycling report, it's true, there really is such a report. The US generated 292 million tons of waste that year. And within that 292 million tons, over 63 million tons of that was food, and another 35 million tons of that was leaf and yard debris. And those tonnages actually equate to roughly the same percentages that are shown in this slide here. Here in Vermont, we actually parallel these national numbers. So let's take a little closer look at the cost of food waste in particular. If we just look at the food waste component of the waste stream, it's a really expensive problem. Food waste is defined simply as food that is produced but not eaten. Every year in the US, approximately 133 billion pounds, or almost 40% of the overall food that we grow here, is wasted. That impacts food security, resource conservation, and contributes to greenhouse gas emissions that comes from landfills. We're wasting enough food to fill the 90,000-seat Rose Bowl Stadium in Pasadena, California, every day. And some studies are now saying we could actually fill it twice a day. A staggering amount of food is thrown out long before it ends up in your refrigerator because we overbuy, we misread labels, we store it improperly, or just forget that we were going to eat that leftover for lunch yesterday. This represents massive implications throughout many sectors of society. Reducing food waste by just 1/3 would be enough to feed the 50 million people who are facing food insecurity in this country every day. Food waste negatively impacts climate change, and sending it to landfills or incinerators prevents food from being used as a resource for other environmentally beneficial purposes. Food waste also contributes to massive financial losses. The value of food wasted in the US currently comes in somewhere between $161 and $218 billion a year. That number attempts to reflect the whole cost of the life cycle of producing our food, resources and labor used for planting and growing, transporting our food the distances it needs to travel to get to us, packaging, storing, disposal, and all the steps in between. Fortunately, the Environmental Protection Agency and the US Department of Agriculture have recognized the urgency and importance of this and the lasting impacts of wasting our food, and have set the first ever goal to reduce food loss and waste by half by 2030. To me, the most amazing part of this goal is the intentional partnerships that have been set with both public and private players to promote action and bring more successful interventions and tools for success. So back to that methane production that comes from landfills. It's about 18 to 20% of the total US methane generation in the country. And it's important to note that not all greenhouse gases are created equal in terms of their contribution to climate change. Their impact varies according to how long they remain in the atmosphere and how efficient they are at trapping heat. For example, carbon dioxide is the most commonly identified greenhouse gas. That's because it's the most prevalent one in the atmosphere. Carbon dioxide is created largely by human activity, and it moves in and out of the air through the natural carbon cycle. Methane, however, is less prevalent and remains in the atmosphere for a shorter duration of time than carbon dioxide, but it's far more intense and much more efficient at trapping heat. Therefore, it is a much more potent greenhouse gas. While landfills are not the #1 producer of methane, they're one of the top 3 contributors. And fortunately, we have a direct way to reduce the source of this potent greenhouse gas by diverting organics towards other more purposeful uses. As you can see here, landfills, when not managed properly, contribute not only to greenhouse gases in the atmosphere, but can also contribute to soil and water pollution. So reducing the amount of food waste sent to landfills can help ease the impact of climate change and address food insecurity for millions of hungry Americans and help divert this valuable resource towards a higher and better use. We've cited the national goal to reduce food loss and waste, and here in Vermont, we've taken some very intentional steps to support this waste reduction goal, along with other effective ways of diverting organics away from the landfill. Natasha is now going to discuss several of those strategies with you.
Thanks, Ellie. I'm going to start by introducing Vermont's Universal Recycling Law, or Act 148. The Universal Recycling Law was passed unanimously in 2012 and effectively bans blue bin recyclables, leaf and yard debris, clean wood, and food scraps from the landfill, with the goal of improving the capture and diversion rates of these valuable materials. Passing the law was intended to send a clear signal to both private and public sectors that these materials would be becoming more available, which was intended as an incentive to invest in both infrastructure and product development to meet the anticipated demand. Focusing in specifically on the food scrap portion of Act 148, this portion of the law was rolled out between 2014 and 2020. Starting with the largest generators with the 20-mile proximity clause and culminating in a full ban down to the residential level, regardless of distance from a certified facility. Here on the right is the food recovery hierarchy that's embedded within the law in order to promote waste reduction, as well as directing the organic materials to a higher and better use, as Ellie described in the previous slides. It's been demonstrated that recycling materials conserves resources while reducing energy consumption and greenhouse gases. Tying back to what Ellie was talking about in terms of food waste, food donation into the charitable food system in Vermont has nearly tripled since this law started going into effect in 2014. And I have to say that this was not an anticipated result from a solid waste law. Feeding people, not landfills, was certainly part of the hierarchy, but the magnitude was far more than what anyone might have anticipated. Vermont's Clean Water Bill, or Act 64, articulates the value of clean waters as a critical community asset that protects our collective health, preserves Vermont natural beauty, enhances the ecological values of our waters, and provides an essential legacy for Vermont's future generations. It outlined a plan to support clean water by reducing sediment and nutrient pollution statewide, and specifically phosphorus pollution reductions for Lake Champlain and the Lake Champlain Basin. It addresses water pollution sources from agricultural runoff, stormwater from developed lands and roads, and addresses specific goals for stormwater management. Importantly, it also introduces a definition of healthy soil into state statute, acknowledging the role that healthy soil plays in increasing the volume of water that can infiltrate where it lands, thereby reducing runoff and erosion. The benefits of healthy soil also include improved revegetation rates, reduced sediment and nutrient pollution, improved resilience to storm damages, and lower long-term maintenance costs. As stated in the Lake Champlain Total Maximum Daily Load Implementation Plan, the major problem is not runoff, but infiltration. And this is where increasing soil health really comes into play. I'm going to talk a little bit more about the required agricultural practices and stormwater management that came from Act 64. A large part of the Clean Water Bill is the implementation of required agricultural practices. Agricultural runoff is a source of nutrient loading and erosion, and the RAPs help reduce damage done to our waters. These standards are intended to improve the quality of Vermont's waters by reducing and eliminating cropland erosion, sediment losses, and nutrient losses through improved farm management techniques and technical and compliance assistance. The RAPs establish nutrient, manure, and waste storage standards, make recommendations for soil health practices, and establish requirements for vegetated buffer zones and livestock exclusion from surface water. The RAPs also establish standards for nutrient management planning and soil conservation. The Clean Water Act also addressed the need to reduce or prevent water quality and flooding impacts during and after development, and to minimize the stormwater impacts through implementation of construction and post-construction best management practices. It also led to the Vermont Stormwater Management Manual being updated, which passed into rule in 2017. The stormwater management permit requirements, among others, include erosion prevention and sediment control measures, as well as a post-construction soil quality requirement of amending disturbed soil to a minimum of 4% organic matter content. You'll learn in the soil health and water quality module why the organic matter content is so important. I also just want to touch briefly on the Municipal Roads General Permit, as this was another specific requirement of Act 64 and the Lake Champlain Phase 1 Total Maximum Daily Load Implementation Plan. This permit requires the reductions in stormwater-related erosion from paved and unpaved municipal roads through stabilization of road drainage systems and reducing the potential road pollutants entering our waterways. Some of the secondary benefits of better stormwater management include increased flood and drought resilience and reduced road maintenance and cost. In all of the practices promoted by the Clean Water Bill, there are opportunities to use compost and compost-based products to meet many of the stormwater management goals. I'm going to pass it back to Ellie, who's going to talk a little bit more about what compost is and how this factors into some of the water quality issues we've been talking about.
Thanks, Natasha. While we won't be discussing all of the super amazing things that compost can do and how it does it in detail right here, you're encouraged to participate in the soil health and water quality module of the Soil Builders program for more detail about that. However, we will be talking about the general definitions and concepts right now. Compost is a soil amendment in organic matter made by the controlled biological decomposition of organic materials. It happens with or without human intervention, but for the purposes of this program, we are talking specifically about intentionally cultivated recipes and resulting finished compost products. It is important to point out, however, that not all compost is the same. Recipe development, the composting process utilized, and lab analysis results dictate the proper application for each compost type. In general, a successful compost recipe will contain the right ratio of 1 part nitrogen to 3 to 4 parts carbon. Nitrogen are things like food scraps, some manures, fresh green yard trimmings. Carbons are leaves, animal bedding, woody materials like chips or shavings, hay and straw. Things often referred to as brown materials are our carbons. The right recipe makes for an aerobic environment, an oxygen-rich environment to make happy microbes who break down those organic materials into an earthy-rich humus to provide a myriad of benefits to the soil. These benefits are achieved through a various range of application options, and those applications are further discussed in the best management practices for compost and compost-based products module of this program. Compost must go through heating and curing requirements to kill pathogen and weed seeds and ensure that the finished compost product is biologically stable and fully matured. And once it's completely cured and added to the soil, it increases the amount of organic matter in the soil, thereby improving the biological, physical, and chemical characteristics of the soil, resulting in several benefits. So how does compost work? Essentially, it increases the amount of organic matter and microbial activity in the soil, thereby increasing overall soil fertility. And when that happens, it improves plant growth and its ability to capture the carbon from the atmosphere, returning it to the soil. So our plants grow bigger and stronger. And once that happens, it improves the soil's ability to store and sequester the carbon that those plants are capturing. And it helps to complete the carbon cycle that happens naturally in our environment. Compost provides slow release nutrients readily available, substituting for the energy intensive fertilizers, pesticides, and fungicides that are often applied to our plants and soils. It increases the moisture holding capacity, reducing energy use for irrigation and increasing resilience to floods and droughts. It also then prevents methane emission from landfills because we're not sending our food to the landfill. We're sending it to be processed into this really great soil amendment. And this is by no means an all-encompassing list of what compost can do and how it can work. It's really just a starting point. So not only does compost work, but it also puts people to work as well. And it makes really good economic sense. On a per ton basis, diverting organics from landfills and making compost employs 2 to 4 times the amount of workers than needed at a landfill. Secondarily, the application of compost creates jobs in a secondary market of green infrastructure in some of the following areas: erosion prevention and sediment control, creating and installing rain gardens, installing green roofs, revegetation plantings of disturbed sites, and perhaps those not even yet discovered.
Thanks so much, Ellie. That's a great summary. Again, this is just to get your appetites wet for learning more about the drivers for clean water and healthy soil and how compost can contribute to soil health and water quality, the best management practices for using that compost and compost-based products. And then the last module that I do want to just encourage you all to participate in is the education and action module, which is really how do we put all of this information to use in our own communities. If you have any questions, feel free to contact me. And again, thanks so much to the New England Interstate Water Pollution Control Commission and the Lake Champlain Basin Program for supporting this project.